Direction of cosines of a vector in 3D. In 3 dimension, OB the origin and XY, and there are XY and Z axis, and along OA a vector A is acting along OA. In the direction OA, vector A is acting. Vector A acts at an angle beta with y-axis, at an angle gamma with z-axis, and at an angle alpha with x-axis. Let alpha, beta and gamma be the angles at which vector A acts with x, y and z axis respectively. Therefore, cos alpha equal, now we can denote the component of vector A along x-axis as vector Ax, and component of vector A along y-axis is vector Ay, and rectangular component of vector A along z-axis is vector Az. So vector Ax, vector Ay and vector Az are the rectangular components of vector A along x, y and z-axis respectively. So cos alpha equal mod vector Ax divided by mod vector A, that is component along x-axis divided by magnitude of vector A, is equal to Ax by A, where alpha is the angle subtended by the vector A with the x-axis. Similarly, cos beta is equal to mod vector Ay divided by A, that means Ay by A, and cos gamma equal Az by A. Here gamma is the angle subtended by the vector with z-axis, that's why in the numerator we should have the component of vector A along z-axis, that is Az by A. Here cos alpha, cos beta and cos gamma are the direction of cosine, direction of cosines of vector A along x-axis, y-axis and z-axis, or with respect to x, y and z-axis respectively. Therefore, cos square alpha plus cos square beta plus cos square gamma is equal to, putting the value of cos alpha, cos beta and cos gamma, we get ax square plus a square plus x square by a square plus ay square plus a square plus az square by a square. Doing LCM, so ax square in numerator, ax square plus ay square plus az square divided by a square is equal to, therefore cos square alpha plus cos square beta, this is cos square alpha plus cos square beta plus cos square gamma. Therefore now what is the expression of vector A in terms of its rectangular components? Vector A equal to ax I cap plus ay j cap plus az k cap. So in this diagram OB the origin, along OA a vector A is acting, and component of vector A along x-axis is vector X, component of vector A along y-axis is vector Ay, this is y-axis, and along z-axis the component of vector A is vector Az, and the vector x at an angle beta with y-axis at an angle gamma with alpha with the x-axis and at an angle gamma with the z-axis. Therefore, cos square alpha mod vector A is equal to ax square root over ax square plus ay square plus az square. Ax, ay and az are rectangular components. Therefore, a equal root over ax square plus ay square plus az square. So putting this value in the expression of cos square alpha, therefore cos square alpha plus cos square beta plus cos square gamma is equal a square plus a square, putting the value of ax square plus ay square plus az square, a square divided by a square. There finally we get cos square alpha plus cos square beta plus cos square gamma as 1. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Hence, we can write the sum of square of direction of cosines of a vector. Direction of cosines of a vector is unity, that means 1. Is a unity, that means 1. Sum of square of direction of cosines of a vector is unity. Additional information, as cos square alpha, again cos square alpha plus cos square beta plus cos square gamma is equal to 1. Therefore, or 1 minus sin square alpha. In place of cos square alpha, we can write 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma equal 1, or comma 3 minus bracket open sin square alpha plus sin square beta plus sin square gamma equal 1. Therefore, sin square alpha plus sin square beta plus sin square gamma equal 2. 3 minus 1 means 2. Equal 2. Sin square alpha plus sin square beta and sin square gamma is equal to 1. That means sum of square of sine of angle subtended by the vector will be unity.